Hi, everyone. Sorry about the lateness of the video. 2 questions for you. Just kind of to make sure you understand what I'm going to be asking for on the test tomorrow. So one question that is getting a lot of kids is, so sine of A, meaning sine of the angle in the A triangle, so to speak, is a ratio of 12 or 13. Now, that angle is between 0 and 90 degrees. Okay, that's fair. Cosine of B, however, B being the theta, so to speak, of another triangle, a second triangle, on a second unit circle, is 3/5. And that one, or that angle, is still in quadrant 1. It just might look a little different in terms of radian measure as opposed to degrees. It's going to ask you for a sum and difference formula or a sum or a difference identity. This particular one's asking for cosine A minus B. So first, we really need to find the third measurement of both of these triangles individually. So we're going to do 2 different triangles in 2 different scenarios. The reason is because we're going to have multiple different measurements here. So this is the A, theta, angle, whatever. This will be the B one, okay? So if in the A triangle, sine is 12 over 13, that means opposite is 12 and adjacent, or I'm sorry, hypotenuse is 13, which means that the adjacent side, I'm going to just kind of quickly do this, would be 5. In the B triangle, if cosine is 3/5, that means adjacent is 3, hypotenuse is 5, and the opposite side is 4. Okay, so now I want to find A minus B. Well, cosine is, the difference formula is cosine of A. Well, cosine of A is 5/13. I don't want to do that. Okay. Cosine of A is 5/13 times cosine of B. Well, we were given cosine of B, so it's 3/5. Okay, that's the first part. And the cosine A minus B formula is a plus. Sine of A, well, we were given sine of A, right? So it's 12/13. And that's going to be multiplied by sine of B, which is 4/5. So I'm taking pieces of information from both triangles and plugging it in here into my difference formula. So now we're just going to multiply. 5 and 3 is 15. And that's going to be over, that's a 65, I hope. Plus 12 times 4 is 48 over, again, 65, which is going to give us 63 over 65. That's my final answer. All right, so again, I'm going to give you 2 different angle measurements from 2 different triangles, and it's a sum and difference formula. Now, if I were to give you just one of these, right, then it would be a double angle formula. So I would say, like, find cosine of 2A, right? So if I give you only one measurement with what quadrant you have to find it in, it's a double angle formula. But if I give you 2, it's going to have to be a sum and difference. So hopefully you know the difference between, sum and difference and then double angle, okay? So that's one of the problems there. The other problems in terms of double angles are going to be like literally just giving you one of these. There's also another possibility of solving an equation like that, but nothing like we did today in class. Way, way, way simpler. Here's the other one that's identity. What is this? Is this your paw print, bro? Look at this. No way. That's way too small. That's weird. Anyway, so we have an identity here. Cosine 180 minus theta equals negative cosine theta. Well, this is going to be negative cosine theta. We just have to prove it, right? So again, we have an identity where A is 180 and B is theta. So we're going to use actually the same formula here, right? So cosine of A, which is cosine of 180. Well, cosine of 180 is negative 1. Times cosine of B. And cosine of theta is just cosine of theta. I can't change anything there, okay? That's a terrible parentheses. I'm sorry. Plus sine of A, well, sine of 180 is 0, times sine of theta. And that's supposed to equal negative cosine theta. Well, negative 1 times cosine theta is negative 1, or negative cosine theta. See what I did there? And then the 0 times, that wasn't funny. 0 times the sine is 0. So we have negative cosine theta equals negative cosine theta. Clearly, the verify is done. So that's one of the problems you'll see too, and it's going to be very simple like that. So understand the top process, obviously. know how to implement and solve and verify double angles, know how to do all those things with sum and difference, and then be able to verify, and you're going to be in great shape tomorrow. Bye. See you later.